Today is August 8th, 2015. I'll do my best to try to explain what's going on and a specific problem astronomers have dealt with for a very long time, but the solution is quite easy once you see it, once you start to understand what's going on. It's an angular momentum problem. Now, astronomers have long believed that the Earth and all the planets in the Sun all formed at the same time, and the planets were remains of the Sun's formation when the Sun formed. And they all formed from a single planar disk, meaning it was more or less a two-dimensional construct. You had this object in the center, not moving, and, well, obviously spinning. And these objects kept on spinning around it as they formed and coalesced into little balls around the Sun. On the face of it, it looks like it makes sense, but they had a huge problem. If everything all collapsed at the same time, and this, as a result of this spinning, that means this object should be rotating the fastest with the most angular momentum, I should say, because it's really massive. And then these objects should carry the lower amount of angular momentum, meaning these objects shouldn't be, they shouldn't have more angular momentum than the central object. This should be spinning like a really fast top, and these would be spinning very slowly. But as it turns out, when we measured the angular momentum and the masses of these, it's the outer objects that have the most angular momentum, and the Sun spins very slowly. So how is that possible? If they all form from a disk, why is it spinning so slowly even though it has the majority of the mass? This should have the most angular momentum in it. So that's the angular momentum problem. And I think that problem will lead us into another set of solutions which completely takes us off the beaten path. I should say, the beaten path, beaten trail. In this understanding, we realized that there was an assumption made that the Sun is the central object, it's not moving, yada, yada, yada. But they were looking at it from a two-dimensional standpoint. The solar system is actually three-dimensional. You have your x-axis, your y, and your z-axis. As well as spheres are three-dimensional. Okay? So you have the angular momentum of the outer objects, and you have a huge mass in the center. The solution to the angular momentum problem is to, well, where's all the angular momentum for the Sun at? Where's it all at? Well, it's easy. It's already there. The assumption that they had was that the Sun wasn't moving. The correction is that the Sun is actually moving through space. And all these objects are orbiting around it as it moves through space. So what's really happening, and yes, I stole this from one of the random YouTube videos, is that you have, we'll just go this direction. You have these outer objects. Well, this object's moving, obviously. But what these objects are doing is orbiting around it in different sine waves. Some sine waves being longer than others. So the central object, the Sun, has always had the majority of the angular momentum, meaning the angular momentum problem never really existed. The problem was that they looked at the Sun as being stationary, when really the Sun is moving through space. And this brings up a whole another set of understandings that I think need to be addressed by the mainstream astronomical and astrophysical community. Is that if the Sun is carrying the majority of the angular momentum and has always been carrying the majority of the angular momentum, that means that the Sun had to have captured the other objects that were in the way. Meaning, migration isn't the rule, capture is the rule of solar system formation. These objects don't change their orbit. No. Once they're captured by the sun, the sun's moving through interstellar space, and I went over this in another video, it just captures the things that are in the vicinity. So granted, it doesn't matter where they are right now. What all that matters is that whatever objects were in the sun's path as it was moving through the galaxy. So say there was a gas giant over here, or a gas giant over here, or a rocky planet over here. That's why you can have a gas giant orbiting really close to the sun, and then you have a rocky planet out here somewhere. It just all depends on where the object was when it was captured as well. Once it captures another, say, object that's like a Jupiter-sized object as it moves through the galaxy, it will induce different gravitational effects on the objects that were pre-existing. So yes, migration can happen, but that's determined upon whichever object gets captured after the fact. So literally we have a huge adopted family which we literally cannot predict which ones came first. We can't. It's impossible. We don't know if Jupiter came first. We don't know if Saturn came first. We don't know if Earth came first or Mercury. We don't know the actual orbital configurations in the timeline of the objects that were adopted inside of our solar system. You can't know. It's impossible. You would have to... It's completely random. But I just wanted to show that to people. And the fact that it was a problem invented before people actually understood what the question was that they were asking. It was a non-question, in other words, or a non-mystery. And we have a lot of non-mysteries inside of the establishment as well, based off of false understanding and, myopic thinking. I'm sure some concepts come to mind, such as dark matter and the absence of neutrinos from the sun and various other things. But just because you can ask a question doesn't mean it has an answer, and just because there's a mystery doesn't mean that it doesn't have there's not some type of thing causing the mystery that you assume to be true that wasn't ever true to begin with. All right, later.